Hi guys, so we are on chapter 7 of Jacob's Algebra. We're working on simultaneous equations, and lesson 4 of chapter 7 brings in the graphing into the picture on everything we've done in the previous lessons. So the first lesson we were learning how to add simultaneous equations to come up with the coordinates or the xy. Lesson 2 we were subtracting. In lesson 3 we were having to tweak one of the first equations to get the same number of x's or the same number of y's using multiplication so that we could then add or subtract the equations. So in this lesson, we are learning how we can use a drawing of the equations, simultaneous equations, a picture for those solutions of those simultaneous equations, and how that can help us, especially with distance, rate, and time problems, as the example Jacobs gives on page 304 and 305 of the greyhound and the kitty cat, and when is that greyhound going to catch up with the kitty cat. So they're basically showing you different ways to graph when you know coordinates, or to use equations to create a graph to find the coordinates. Let's look at some of the problems. Let's look at the example that they use in the book. Anytime we're dealing with distance and time as the greyhound and the kitty cat, we're really just dealing with the same formula of distance equals rate times time. And what they've done is they're calling y the distance, and they're calling the x time. So when our rate changes, we are solving for distance and time. So looking at the first equation up top of the dog, what that's telling us is that he can run a certain distance total, given that he can run 15 meters per second. And the second equation is telling us that our kitty cat starts this, when this chase starts, he is 30 meters away from the dog, and he can run a distance of 10 meters per second. So we are basically going to take that information and graph it to find out when the dog catches the kitty cat. So thinking about the other formula or equation we know that our slope-intercept is y equals mx or ax, whatever letter, plus b. And we know that the b tells us where on the y-axis that the line's going to intersect, and the m tells us our slope, which is rise over run. So if we look at the first equation up here of the dog, we know that b is 0 because it's not in there, but that it is set up as the standard form. So we can assume b is 0. So if I set up I always encourage this, if I set up my XY table, then I know that if b is 0, the slope, or the rise over the run, is 15 over 1. So we plot this. We go to the y-intercept of 0, and we know it's at, we start going up increments of rising up 15 and going over 1. And so if you look at that, you can see that our dog there in purple starts at the y of 0, okay? And then we are going over 1 and up 15. Let me see if I can get this to work for me a little better. So we're rising up 15, and then we're going, so go up the y to 15, and then we're going over 1. And we continue up that track, going up 15 and over 1. And we follow that up, and we come to, come to 6 and 90. So when we get on the graph to x of 6, we are up at y of 90. And then for the kitty cat, if you look at the next equation there, we know that we have to get this in standard form first to manipulate it. So let me get a little space here. And let's put that second equation in standard form. So y equals 10x plus 30. That gets us to our standard form. And we know that this is the slope. This is the intercept, and this is the slope. 10 over 1. And so when we plot that out on the graph, we find that the kitty cat also has the coordinates of 6 and 90. 6 being our x and 90 being our y. And then we plug those numbers in if we want to check. Now in set 2, they're giving us a graph of the equations. They're asking us to find the coordinates visually and then plug it into the equations they gave us and see if our coordinates are correct. So again, looking at this graph that they already give, you just find where the coordinates, where both lines, where their coordinates meet. And we see that they both meet at the 4x and the y negative 1. So we have the coordinates 4, negative 1. So if we take our equations here and just plug in x and y, we work it out and we see that the solutions are equal on both sides for the first when we plug in that 4 and negative 1, and also for the second equation they are equal on both sides of the equation. So our coordinates of 4 and negative 1 is our answer, and we've checked it and it's correct. So that's how we work out those problems in set 2. Also in set 2, starting with number 9, it asks us to check each solution by seeing if it makes each equation in the pair true. So what we have to keep in our heads is that we have to make sure our equations are in our standard y-intercept form so that we can know what is the slope and what is the y, so that we can figure out these equations. So I went ahead and set up my XY tables for each equation over on the right. I had to manipulate this equation because, as you can see, it's not in standard form of having y by itself. So I moved x over, but in the standard equation x comes first, so then I massaged that. So the answer, or the setup, was y equals negative x, since we subtracted x to both sides. So y equals negative x plus 3. So now I'm ready to start throwing in some x, y coordinates. So given if x is 0 for the first equation, if x is 0, I plug that in, y equals 2x. So y equals 2 times 0, then y would also equal 0. And then I plug in 1 to the equation to see what I get for y, and then 2 for x to see what I get for y. And these are what I get, and I do a couple of them. Then I do the same thing for our second equation, and I notice that both equations have the same coordinates of 1 and 2. So I assume that where they cross on the graph, where they meet, will be at an x of 1 and a y of 2. So we'll just simply plug that, double check and plug that into the equation, which we really don't have to do because we've already done that, but just for our example. So y equals 2x, y equals 2x is 1. Hold on, excuse me. Y is 2. So 2 times 1 is 2, and y is 2, so that's correct. And then we do it also for the second equation if you want to be doubly sure. If they're more complex equations and you can't just simply eyeball and look. So that's how you solve to find the coordinates given that example in the book on number 9. And then we go to set 3, where they are asking us to find the solutions of the pairs of simultaneous equations by graphing them, not doing any computations. So, and then we need to check at that point to make sure each is true. So we go back again, remembering that what our standard form is. Our standard form is y equals mx or ax, whatever letter, plus b. Okay, and we know this will tell us where it crosses the y-axis, and this tells us our slope of how it's going to run and rise, or rise and run. Okay, and it's really rise over run. Okay, so looking at the first equation, it is in standard form, and so we know that b is 0. So the red dot on the graph is where I would put the first at 0, 0. And again, so I don't get confused, I really find it helpful to make a table. So when y is 0, x is also 0. Okay? Now, we already know that all we have to do, though, is rise and run. So in this, we start at 0, and we're going to rise, we're going to rise 1. Okay, we're going to start at 0 and go up 1, and then we're going to go over 2. And so you'll see that our next point is at the coordinate of x is 2 and y is 1. And then we do it again. We go up, rise up 1, and over 2, and we mark our coordinate. And we do a few of those. The one thing I want to remind you of while I'm writing this that we found is that when you're manipulating the rise and the run, so in our first equation it's 1/2. If we want to go the opposite, we have to do the inverse of our positives and negatives. So in this one, we have a +1 and a +2. So if we want to put how our line's running in the inverse, then we just make it negative. So in that case, if we're starting at 0 again, looking at that graph, we would go down a -1 or fall, and then we would move left 2 steps, and then we would have our dot, and then we would do the same thing. Okay, so our other coordinate then, just so we could graph it nicely, we would have x is -2 and y is -1. So that's what we've graphed. So now let's move to draw our line there and move to the next equation. X plus y equals 6. And in that case, it is not in standard form yet. So we need to quickly get it into standard form, which I have done, and gotten y by itself. And we see that y equals -1, and I like to put my rise and run there, so I always put it over 1 when it's a whole number, -1 over 1x plus 6. So I know that my first dot, or my first coordinate, will be up at x is 0 and y is 6. And so I plot that up there on the graph. And then I know my rise and run, I will rise, which is really fall, right, when it's negative. I will fall down 1, and I will run over a +1. And I can continue to do the fall, the run and the fall, or the fall and the run, until I get to where the two meet. And we see that our coordinates of where they meet is x is at 4, right? And it's also at y of 2. Then our next step is simply to plug x and y into both equations and solve for them. So let's do the first one quick. Y equals 1/2 x, where y is 2, and x is 4. And because I have a fraction, I'm going to do 4 over 1. And we know that 4 over 2 is 2, and we can simplify that where 2 equals 2. And we do the other equation of x plus y equals 6. X is 4, y is 2, and we see that we have found where the correct coordinates, where they intersect. So that's how you'll do 19, 20, and 21. Okay guys, so I hope that helps you to work out your sets and understand how you can take what you've learned so far in chapters really 6 and the first few lessons in 7 and apply them to graphing. If you have any questions, you know you can always rewatch the videos or contact me. Until next time. Bye.